Hello everyone, welcome to the third session of Bridge course on physics. So I guess most of us would have either attended the first and second sessions. If not, you would have at least gone through the recorded lecture content for that. So what we will do in this third session is a sort of another basic area with regard to physics, which is about the measurement of physical quantities. So in the first and second sessions, if you guys would have attended those sessions, then you will know that we have basically covered about the classification of physical quantities into scalars and vectors. So we talked about how vectors are different from the normal scalar quantities and how we are going to deal with vectors. So if we are going to add two forces, we cannot add them just like numbers. We have to follow some addition law, which we call as the vector law of addition. Since vectors are going to be one important set of physical quantities, the operations in vectors are important, and so if we have good understanding of that, then most of the chapters will find it useful. In this session, what we will be looking at is we will try to cover the idea of what we call as units and dimensions of physical quantities. So whenever we have any physical quantity, we talk about the units of the quantity, we talk about the dimensions of the quantity. And just like I keep asking you guys in every session, so if you have any doubts or queries while we are going through the lecture, you can just keep typing in the chat box so that I'll be able to clarify it then and there if it's a very basic query. If not, I'll make it a point to clarify it at the end of the session so that you'll have continuity before you come for the next session. Okay guys, so we'll get into the session now. So what we are basically going to cover in today's session is the understanding of physical quantities in terms of what we call as the units and dimensions aspect, and we will also learn how do we relate different physical quantities. See, as I might have already told you guys in the first session or second session, I am not really sure, that in entire +1 +2 syllabus we might see roughly around 200 plus kind of physical quantities. Even up to our 10th standard understanding, right, we may have covered some 50 plus kind of number physical quantities. Like we have learnt about force, we learnt about displacement, we have learnt about acceleration, we learnt about current, we have learnt about charge, time, so temperature. So some like 50 plus kind of number we might be already aware of it, and we are going to be increasing that number up to 200. So it is not like all these physical quantities are separate. It is not like they are independent. So these physical quantities, they are going to be having some relation between them, and what kind of relation they are going to have is something that we will be covering in this session. So we are going to cover what? We will be covering about the idea of units and dimensions of physical quantities, and also we will be learning how the physical quantities are related to each other. Okay guys, so we'll get into the session. So first part of the session will be about the units, and in units also we'll talk about relation between the physical quantities. The second part of the session will be about the dimensions. In dimensions also we'll cover about the physical, quantities relation between them. First, if I say a physical quantity, what is a physical quantity? Because physics is mostly about what? Measurements. If physics is about measurements, what we are measuring is basically what we will call as a physical quantity. So physical quantity is what? A quantity that can be measured by instrument and which is clearly defined and has proper units. So what is it? It's something which can be measured. That's very important. If something is not measurable, we will not call it as an physical quantity. Like say for example, we will keep saying, oh, this guy has got a lot of mental strength. Now, what is mental strength? Can we call mental strength as a physical quantity? No, we cannot call it as a physical quantity. Why? Because we cannot measure it. It's a colloquial term that we'll use, but we cannot measure it. But if I say for example, distance between Chennai to Delhi is some 2300 kilometers, that is measurable, distance is measurable. If I say time, like the lockdown has been happening for last nearly uh, 30 days, then the time is a measurable quantity. So anything which we can measure it and has proper units, this is important. So when we are measuring it, we will measure it with the help of unit. Like I said, what is the distance between Chennai and Delhi? I said 2300 kilometers, means I am using the unit kilometer. If I say the time of the lockdown that is happening currently for the COVID-19, then I am saying it is nearly 30 days, means I am using the unit as day. So the physical quantities are something that we will be using in physics, and all the terms that we'll talk about in physics, whether it is length, mass, time, force, all of them we'll be calling as what? Physical quantities. If you look at the physical quantities, right, we will consider the physical quantities to be in these two categories. One set which we will call as fundamental, and the other set is derived. So I'll tell you why we are classifying it as fundamental and derived. We are classifying it as fundamental and derived to understand the relation between the physical quantities. So first I'll explain to you what is this classification of fundamental and derived, but let us just understand that there is a classification. All the physical quantities, right, like we are going to learn about some 200 odd physical quantities. So what we are saying, the 200 odd physical quantities, we are going to divide them into what? Fundamental set and then derived set. Clear, guys? So this is how we are going to classify the physical quantities. Now what is this classification of fundamental and derived physical quantities? The physical quantity which does not depend on any other physical quantity is called as what? Fundamental physical quantity. So what is a fundamental physical quantity? That is not going to depend upon any other thing. Like say for example, length is there, mass is there, time is there. We will call them as what? Fundamental physical quantities. And the other set is a derived physical quantity. Means that is self-explanatory. Means what? These quantities, we obtain them or we derive them. We basically obtain them or we derive them from the fundamental set. So we have a set of fundamental physical quantities, and using those fundamental physical quantities we will derive the others. All the other derived physical quantities, right, we will be calling them as derived physical quantities. So this is the classification of physical quantities into fundamental and derived. Now we'll see what are the examples of the fundamentals and what are the examples of the derived. But before we go to the the details of what physical quantities we will call as fundamental and what physical quantities we call as derived, we must keep one thing very clearly in mind. When we have divided the physical quantities into fundamental and derived, this classification, right, has to follow these two ideas. One is it must be exhaustive. Means what? All the physical quantities, we may be learning about 200 odd physical quantities in +1 +2, but we may have more than that in our higher standards. If we go and do MSc physics or applied physics or some other branch of advanced physics, we will know that there will be even more physical quantities, and all of them we must be able to cover in this classification. Means the classification must be exhaustive. We cannot leave anything out. So I cannot leave one quantity and saying that okay, this is neither fundamental nor derived. I can't keep anything outside. It should be put into the classification. First point is it must be what? Exhaustive. The classification must be exhaustive. Second point is the classification must be exclusive. Exclusive means what? It is either this or that. We cannot have both. Like say for example, I am talking about something like impulse. Means impulse, we will learn about it as we go into the mechanics part of physics. If we say impulse, right, impulse is going to be a derived physical quantity. Impulse will be force into the time for which the force is acting. So that is how we will measure the impulse. So impulse will be derived. If I say temperature, temperature will be fundamental. I cannot have one physical quantity occupying both the places. Means either it is a derived quantity or it is the fundamental quantity. The classification must be what? Exclusive. Any physical quantity you take, it is either in this category or in this category. So these are the two ideas that we have to keep in mind while we talk about the classification. Okay. So this is very important, because even in some of the previous years, right, there have been questions asked which try to check whether we understand the basis of this classification or not. How do we classify the quantities into fundamental and derived? If you look at the fundamental physical quantities, which are supposed to be independent, they don't depend upon any other physical quantity. The fundamental physical quantities are 7 of them are there. So some of them we are very much familiar with, and some of them we may be seeing very rarely. So look at the 7 set of fundamental physical quantities, guys. Maybe you can repeat along with me. What are the 7 physical quantities? Fundamental: length is 1, mass is 1, time is 1, then electric current, then temperature or thermal temperature, then quantity of matter. What is this quantity of matter? Quantity of matter is not mass. Quantity of matter is in terms of the moles. This is mainly something that we will be using in chemistry. I mean, we will use in physics also to some extent, but mainly we will be talking about this in chemistry. Then we have luminous intensity. This one even in our entire +1 +2, right, we will not cover much about it, because this is something that is related to the intensity of light, which we use very rarely. In fact, we have only 2 chapters related to light. One is called as ray optics, and other one is wave optics. So in these 2 chapters we will not talk much about the luminous intensity. We will talk about the other things, but we will not talk much about the intensity of light. But this is also a fundamental physical quantity. So how many fundamental physical quantities are there, guys? There are 7 fundamental physical quantities. What are those 7 fundamental physical quantities? Length, mass, time, electric current, temperature, quantity of matter, and luminous intensity. These are the 7 fundamental physical quantities. Okay. And other than these 7 fundamental physical quantities, rest all should be what? Derived physical quantities. Now derived physical quantities, right, are basically related to the fundamental set in different ways. So they are all derived from the fundamental set. Now we'll see how these derived physical quantities are obtained from the fundamental set. But before that, let us look at this question. This question basically checks if our understanding of the classification of the physical quantities is correct or not. Maybe those who know the answer to this, right, you can just type it in the chat box. So I'll just read the question first. In a hypothetical case, means this is not a real case, it's a hypothetical case. There are 99 physical quantities, of which 9 are fundamental. So how many are fundamental, guys? 9 are fundamental. But for us, how many are fundamental? 7 are fundamental. So this is a hypothetical case. Okay. And rest all are derived. Means 9 are fundamental, 90 must be what? Derived. If a new 100th quantity is identified, so somebody is identifying the 100th quantity, okay, which has no relation to the existing fundamental set. So the 100th quantity has no relation to the existing fundamental set. What must be the classification of this new quantity? So how do we classify this new quantity? So let me give you options. So you can choose the options. I'll give you 4 options. First option is we will call it as derived. Second option is we will call this as fundamental. Third option is either fundamental or derived. Fourth option is neither fundamental nor derived. So look at these 4 options, guys. Those who know the answer, you can just type it in the chat box so that we'll see who is getting it correct. So we need to identify this new 100th quantity, right? How it is going to be classified? Is it going to be a derived one, or is it going to be fundamental, or either fundamental or derived, neither fundamental or nor derived? Yes, guys, some of you I think are getting it right. So Some of you are getting it right. They are saying it is a fundamental physical quantity. So the correct answer is it is a fundamental physical quantity. The 100th one should be called as a fundamental physical quantity. So we'll see how it is going to be called as a fundamental physical quantity. But before we go there, right, let us look at the options given to us. What are the options given to us, guys? A is derived. So can we call it as a derived? See, they are saying that the 100th quantity which is identified has no relation to the existing fundamental set. When do we call something as derived? We have fundamental set. If we can derive this, if we can relate it to the fundamental set, we will call it as derived. If we are not able to relate, means we cannot call it as derived. So that option is gone. We cannot call it as derived. And look at option C. Option C is saying what? Either fundamental or derived. This is not at all possible, because remember the two ideas what we said. The classification must be exclusive, it must be exhaustive. So if I say it is either fundamental or derived, it is ambiguity. The classification is not having ambiguity, it is exclusive. So we cannot say either this or that. And option D is saying neither fundamental nor derived. This is also not possible. Why? Because the classification is exhaustive. We can't leave anything out. Even if some new quantity is found out, right, we must be able to put this into any of the two categories. So the 100th one, which has no relation to the existing fundamental set, should also be called as a fundamental physical quantity. So thereby, in this case, in the new scenario, right, we are going to have 10 fundamental and the remaining 90 will be what, guys? 90 is going to be derived quantities. Now almost a similar thing happened for us also. While initially the angles are not thought so much related to science, they are thought more in terms of mathematics, but later it is found that we do use angles in physics, especially when we talk about the idea of the angular motion or circular motion. So if a particle is going in circular path, right, what do we call it as? Circular motion. So angular motion or circular motion, and even in the other parameters, right, we are going to be using angles in science. So there are two types of angles we will use. One is the angle that we measure in a plane, like we draw two line segments and the angle between them, right, is a angle that we measure in plane, and that is basically called as plane angle. This is one type of angle. Plane angle can be also called, by the way, as 2D angle. And the other type of angle is a solid angle, which is also called as 3D angle. Like if you look at a cone, right, I mean, I'm sure all of us would have seen this ice cream cone. Not sure you guys are getting it in this summer or not, but yeah, the ice cream cone, if you see at the tip, right, if you look at this, okay, I have one cone like this, another cone like this. I'm sure a lot of us will prefer this one because it is going to hold more amount of ice cream, okay. But that apart, you see the angle over here, right, that the tip of the cone, the angle that we have is basically not an angle in a plane, it is a 3D angle. So at the vertex of the cone, right, the angle that we are forming is basically a 3D angle. So that is what we will be calling as the solid angle. Just the definition of solid angle we will see here, but in our physics, because at least in the +1 +2 level, right, what we will be having is mostly the visualization of 3D only. We don't have the real applications of 3D level problems. Mostly our physics problems will be confined to 1D and 2D and 3D visualization. So we'll see the definition of solid angle, but we don't use the solid angle much. So these two quantities, right, they have also been found to be related to science, and they are not related to any of the existing fundamental set. Remember, we already have how many fundamentals? 7 fundamental physical quantities. Okay, I think you guys can recall what are the 7 fundamental physical quantities, guys. Length is 1, mass, then time, then temperature, then current, then amount of substance. Okay, then what is the next one, guys? The luminous intensity. So these are the 7 fundamental quantities. The plane angle and solid angle, right, they are not at all related to the 7 fundamental. So just like the case we saw in the previous illustration problem, these also must be categorized as fundamental, but they have something different from the fundamental quantities. So we will not call them as exactly fundamental, but we will be calling them as supplementary physical quantities. So what we'll call the plane angle and solid angle, supplementary physical quantities. So by that we have 7 fundamental physical quantities and 2 supplementary physical quantities. So this is the set of physical quantities we have. So we have 7 fundamental, 2 supplementary, and rest all are derived. Means we can relate any other quantity to either the 7 fundamental or the 2 supplementary. So we can relate all the other quantities to this 7 plus 2 fundamental plus supplementary. So this is what we have in terms of the relation between the physical quantities. Okay guys. Now let us come to the important idea, which is about the units, because this part of the discussion is about what? Units of the physical quantities. So what do you mean by units of the physical quantities? So if you talk about unit of a physical quantity, right, unit is nothing but the base value for expressing the value of measurement. Like say for example, if I say that the distance between 2 points is 2 centimeter, means what? There is something called as a centimeter, which is the base value, and this is 2 times of that. If I say that the time that is gone by from the beginning of our session is say for example 35 minutes, means what? There is something called as 1 minute in terms of unit value, and the time that has elapsed is 35 times that of the minute value. So the base value of expressing the measurement is basically what we will call as an unit. Okay, and if you look at the units, there are 2 types of units. One is a standard unit, other one is a non-standard. So what is a standard and what is a non-standard? And by the way, it is been agreed upon that we will not be using these non-standard units in terms of scientific calculations or scientific measurements. So what is this classification of units into standard and non-standard? If you look at somebody measuring temperature as the, say for example, the daytime temperature, this is a common word that we'll keep using. So we'll say that store this under daytime temperature conditions. What do you mean by the daytime temperature condition? If you look at the daytime temperature condition, maybe in India the daytime temperature might be around 25 degrees centigrade in normal days. In summer it might increase, in winter it might decrease. If you go to some cold country, right, the daytime temperature may be less than 10 degrees. So such units. And also, like say we talk about, say for example, length of day. In the olden times, when these watches and all these things are not there, the people who will come for work, they will be coming for work based upon the length of the day. So they will say you come at the sunrise and then you leave at the sunset. So they will count it as 1 day. So the guys will be working for one length of the day. So the length of the day is also not standard. Why? Because if you look at for us, right, normally the length of the day will be 12 hours. Length of the day means I'm talking about the day where the sun is available. So we'll have 12 hours of daytime and 12 hours of night time. But if you go to some polar regions, right, the North Pole or South Pole, the length of the day will be very less. It may be even sometimes 4 hours. So the day will be shorter and the night will be longer. So the units like this, we will call them as what? Non-standard. Even sometimes when we are standing in prayer in school, right, the prayer time, what they'll say is maintain 1 arm's distance. You'll see that the guys who are having a longer arm, between them the distance is going to be longer. The guys who are having a shorter arm, right, for them the distance is going to be shorter. So if you say that the unit of distance is arm's length, then that is also non-standard. Why? Because it will change from person to person. Whereas if you talk about a centimeter, if you talk about a meter, these kind of units will be called as what? Standard units. Okay, so the standard units are those which are going to be not changing, and the non-standard, they will change depending upon person to person, or depending upon the place to place measurement, or depending upon the time to time measurement. So we will be considering only the standard units for the measurement. We will not consider the non-standard units, because they will be changing from situation to situation. Either they will change from place to place or person to person. And if, say for example, we are having a drug, and we know that the drug has to be kept at say for example 25 degrees centigrade. We send the drug to some cold country, like European countries or something, and we don't say that the temperature has to be 25 degrees centigrade. We'll say that the temperature should be daytime temperature, because we know that daytime temperature for us is what, 25 degrees centigrade. But over there, if you go to the European countries, right, the daytime temperature may be less than 10. And if they just do that, if they just store this at the daytime temperature, for that what will be the daytime temperature value? 10 degrees centigrade. So the drug might actually get spoiled. So the scientific information is always given in terms of what? Standard units. Now if you look at these standard units, it is not like we have just one standard unit. We have many standard units. Like for just we talk about the distance, right? Distance can be measured in terms of meter, centimeter. If you talk about the distance between two places, we'll give it in terms of what? Kilometers. If you talk about the distance at the small particles level, we'll talk in terms of micrometer, and even smaller ones. We'll see that in the discussion. There will be smaller units called as a nanometer, angstrom unit. And if you talk about the distance between the galaxies and solar systems, we will talk in terms of light year. So, and astronomical unit. So all these are the distance units. All these are standard units. It is not like they are non-standard. All of them are what? Standard. So we have not just one standard unit, but we have many standard units. Lot of them have come because of the historical reasons, and because of the need for having certain values in specific measurements. Like if we talk about the measurement of the distance between two particles at the small level, right, we cannot measure this in terms of meters. We have to measure it in terms of small unit. If you want to talk the distance between two places, we cannot talk it in terms of the small unit. We must talk in terms of large value. So the units that we use, they are many of them. And why do we have many of them? Because of historical reasons is one, and also because of the need to use. Like say for example in US, if you go to a petrol bunk, right, then usually they will fill petrol in terms of gallons. And if you look at any grocery store in US, you go and talk about buying something, they will always give it in terms of pounds. Whereas if you come to India or some other country, the petrol you will be getting it in terms of liters, and normal things that we buy from the grocery stores and all that, right, you will be getting in terms of kilograms or grams, etc. So because of the historical reasons, they have been using pound, gallon, and all those kind of, even distance there will usually be talking in terms of feet. But here I will talk mostly in terms of what? Meters. Of course nowadays we also see that the plot area or the flat, like if you are getting into a new flat, or your parents are going into a new flat, you will see that the person who is selling it, right, they will say it is a 1500 square feet flat. The square feet will be in terms of the area that is there. So the historical reasons, and then the need, these are the two reasons why we have so many units. Now if you look at all these units, right, we will be required to change the value from one to other. Like somebody is saying in terms of the distance in feet, and we are calculating everything in meters, so we must be able to change the distance in feet into meters. Somebody is saying mass in terms of pound, we are having all our measurement in terms of kilogram, so we must be able to change pound into kilogram. So we need to understand what is the relation between the units. And if you look at the relation between the units, right, we have two kinds of relations. One is the prefix based relation, second is the definition based relation. So definition based relation is basically for completely different physical, different units of the physical quantity. We will go to the definitions of each of the units, how these units are defined, and then relate them based upon the definitions. We will see the examples of that. The other one is a prefix based relation. So what is a prefix based relation? First of all, if you have a unit like meter, which is the we'll see that we'll call it as SI unit. I'm sure you guys would have heard about this SI system of units. We will also cover this in this particular lecture. So if you have a meter, which is a reasonably long distance, but we want to measure even longer distances, like we want to measure the distance between two places, we want to measure the distance between two planets, we want to measure the distance between two galaxies. So when we want to increase the value of this unit, we can use a suitable prefix to increase the value. And what are the prefixes that are used to increase the value? Guys, you might be already aware of them. So if we use a prefix deca, the symbol that we use for this is dA. That means what? 10 power 1. So decameter, if I say decameter, right? So if I say decameter, what is a decameter meaning? It will be 10 power 1 meter. So if you say hecto means what? 10 power 2. So these are important, guys, we might have to remember them. Kilo means, this is something that we are all familiar with. Kilo means what? The symbol is K we use, and kilo means what? 10 power 3. Mega, symbol is capital M. Mega means what? 10 power 6. Then from here onwards we will see in terms of multiples of 1000. After mega, what will come? Giga. So this is something that we will be aware of in terms of our the system memory usage. We'll talk about what? Kilobyte, megabyte, gigabyte, terabyte, like that. Okay, so mega means 10 power 6, giga means what? 10 power 9, tera means 10 power 12, then comes peta, 10 power 15, then comes exa is what? 10 power 18. So we'll not go this much, but we must at least be familiar with up to tera. So what are these prefixes used to increase the value, guys? You can just repeat along with me. What are the prefixes? Deca means what? 10 power 1. Hecto means what? 10 power 2. Kilo means 10 power 3. Then mega means 10 power 6. Giga means what? 10 power 9. Then tera means 10 power 12. So these are the prefixes used. Maybe you can just make a note of this also. These are the prefixes used to increase the value of the unit. So generally when we talk about distance between two places, right, like distance between Chennai and Delhi, what we are saying? 2300 kilometers means, kilometer means what? Kilometer means 10 power 3 meter. So we are using kilo prefix to increase the value of the unit meter. Okay, guys. Then the other side is decreasing the value. So we have a meter, we want to decrease it. We want to measure the distance between two particles. We want to measure the size of the atom. We want to measure the size of the nucleus. So when we go to smaller lengths, we have to decrease the value of the unit. So how we will decrease? A prefix deci. Symbol is what, guys? D. So dm means what? Decimeter. So what is the decimeter? 10 power minus 1. Then we have prefix centi, 10 power minus 2. Then we have milli. Milli means what? 10 power minus 3. Then micro, the symbol is mu. How do you spell it, guys? The mu is how you will be spelling it. Okay, mu will be what? 10 power minus 6. Mu is micro. And n will be for nano. Nano means what? 10 power minus 9. Okay, so the nanotechnology and all these things that we'll talk about, right, it is basically related to the technology of particles which are in the range of nanometer, means 10 to the power of minus 9 meter. So all the nanotechnology things that we talk about, right, they are involving particles which are in the range of 10 power minus 9 meters. So this is what is a nanometer. Then we have pico. Pico means what? 10 power minus 12. Generally, if you see, size of the atoms will be in the range of nanometer, and if you go to nanometer to picometer range. If you look at the size of the nucleus, it will be in the femtometer range. Femto means what? 10 power minus 15. Then we have auto. Auto means what? 10 power minus 18. This is a very, very small unit. So these are the prefixes used to decrease the value of the unit. Okay, so just look at this, guys. What are the prefixes used to decrease the value of the unit? We have deci. Deci means what? 10 power minus 1. We have centi. Centi means what? 10 power minus 2. We have milli. Milli means what? 10 power minus 3. We have micro. Micro means what? 10 power minus 6. We have nano. Nano means what? 10 power minus 9. We have pico. Pico means what? 10 power minus 12. We have femto. Femto means what? 10 power minus 15. We have auto. Auto means what? 10 power minus 18. So these are the prefixes used to decrease the value of the unit. Clear, guys? Now this is what we are calling as the prefix based relation. So when you see a kilometer, centimeter, a decimeter, or a millimeter, micrometer, they are not too different. They are all related to the meter by the prefix relation. So one set of relations are over. The other set is the definition based relation. Means fundamentally there is no correlation between these two units. So we'll go to the definition and relate them. Like, this we will just pick up two examples because we have only a shortage of time in this session. We'll talk about the units of length, and we'll talk about the units of the mass, and see how we have these definition based relations. So look at it, guys. In terms of length, right, we have something called as astronomical unit. It is a very large distance unit. And what is this, guys? Look at what is the definition of astronomical unit. It is the mean distance between sun and earth, or it is also the mean radius. Remember what we say, earth and other planets, they will revolve around the sun in elliptical orbits. The orbits are not circular. The orbits are what, guys? Elliptical orbits. So elliptical orbit means what? It will not be a circular orbit. See, if sun is at the circle center, means distance from earth to sun will be always fixed. But in case of ellipse, it is not going to happen like that. Ellipse means the distance will be different. So the mean distance between sun and earth is called as what? The astronomical unit. And this is generally used in case of solar studies. So what is an astronomical unit, guys? 1.5 into 10 power 11 meters approximately. Okay, so approximately what is it, guys? 1.5 in 10 power 11 meters. This is a long value for the distance. And we have one more unit that is usually talked about in terms of the distances related to the astronomical sciences. That is 1 light year. What is a light year? It is 9.46 in 10 power 15 meters. And we'll see how this value comes. This light year is nothing but it is the distance traveled by light in vacuum in 1 year. So 1 year means what, guys? 365 days. So in the 365 days, if the light is traveling at 3 into 10 power 8 meters per second speed, it is going to cover this much distance. So that is what we call as the light years. Generally, when we talk about the distance between galaxies, right, we will be talking in terms of the light year. When we are talking in terms of the distance between the objects within our solar system, we will talk in terms of the astronomical units. Then there is one more unit which is called as parsec. So parsec is nearly 3.1 in 10 power 16 meters. It is the distance at which the mean radius of Earth orbit subtends an angle of 1 second of arc. So what is it, guys? It is the distance at which the mean radius of the Earth's orbit subtends an angle of 1 second of arc. Means if we have the properties of the arc, remember, guys, the length of the arc is what? The length of the arc is the Earth's orbit, means astronomical unit, and the angle here is what, guys? 1 second. 1 second means 1 by 60th of a minute. What is a minute? Second and minutes are smaller units of angles. What is a minute? A minute is again 1 by 60 of a degree. So I can say 1 second will be equal to what, guys? 1 by 3600 of degree. So if you have this radius, what is the distance at which the mean radius of Earth's orbit? This is the astronomical unit. This will be subtending how much angle, guys? 1 second angle. So this we will find by using what? The properties of the arc. So this we will find by using the properties of the arc. So this is what we will be calling as the parsec. Okay, guys. Now we'll see some more distance units. Planck length. So Planck length is a smaller value, which is the distance traveled by light in 1 Planck time. So what is a Planck time? 10 power minus 43 seconds. And the distance will be approximately 10 power minus 35 meters. This is a very small unit of length. Then we have one X-ray unit. These things you can just make a note of it, guys. We may not be really required to look at them. X-ray unit is going to be what? 10 power minus 13 meters. Now this is important. Angstrom unit. What is angstrom unit? This is something that we will be using when we talk about the wavelength of electromagnetic waves. So whenever we are talking about the wavelength of electromagnetic waves, right guys, we will be using the angstrom unit. What is one angstrom unit? 10 to the power of minus 10 meters. The symbol for angstrom unit is what, guys? A will keep and then one circle over the A, circle on top of A. This is the representation for the angstrom unit. Okay. Then we have 1 foot. So 1 foot will be what? 30.48 centimeters. So 1 foot will be 30.48 centimeters. Then we have 1 ad. Ad will be what, guys? 0.91 meters. So we can remember these. These are important. Angstrom, 1 foot is what? 30.48 centimeters. This one is, the ad is not that much familiar for us, but these are the units of length for which we can only do the conversion based upon the definitions. So if only we know the definition of how we will define a Planck's length, we can relate it to the meter. Otherwise we cannot relate it. If only we know the definition of foot, we can relate it to the meter. Otherwise we will not be able to relate it to the meters. So this is what is the conversions based upon the definitions. Now we'll just take a look at quickly about the mass also. For mass, if you look at, there is a popular unit of mass which is called as Chandrasekhar unit. So Chandrasekhar unit is 1.4 times mass of sun, which is 2.8 into 10 power 30 kg. So Chandrasekhar unit of mass is generally used for defining the mass of celestial bodies. Okay, so what is the value, guys? 1.4 times the mass of sun, which is going to be 2.8 in 10 power 30 kilograms. Then we have a metric ton. What is a metric ton? It will be 1000 kg. So generally when we want to talk in terms of the goods and services, we'll talk in terms of what? Metric tons. Then we have a quintal. Quintal is what? 100 kg. So if you are having paddy or grain bags, right, we'll talk in terms of quintal. 1 quintal, 2 quintal. What is a quintal? 100 kgs. Then we have atomic mass unit, which is 1/12 of a carbon 12 atom mass. This definition you might have seen in chemistry. And what is the atomic mass unit AMU value, guys? 1.66 into 10 to the power of minus 27 kg. What is AMU or atomic mass unit? 1.66. This is important, guys, among all of them. 1.66 into 10 power minus 27 kg. This is the atomic mass unit definition. And pound is a unit of mass that is generally used in some countries. 1 pound will be 0.45 approximately 0.45 kg. I mean, here we are giving it up to even more decimal places, but approximately what is 1 pound, guys? 0.45 kg. So these are some of the common units of mass for which we will look the definition based conversions. So in this we will mainly focus on what? Metric ton is what, guys? 1000 kg. Quintal is what? 100 kg. Then atomic mass unit is what? 1.66 in 10 power minus 27 kg. What is atomic mass unit definition? It is the mass, see, it is 1/12 of carbon 12 atom mass. Okay. And then we have pound. What is 1 pound? 0.45 kg. Clear, guys? So these are the kind of definition based conversions we can have. Now we'll come to the last part of this units discussion, guys. So this part we will talk about what we call as the system of units. So while there are so many standard units, these standard units are put into what we call as certain systems. What do you mean by the systems? System is basically an idea where we collate the units of fundamental quantities. So we have the fundamental quantities, we collate the units of the fundamental quantities into one group which we call as system. And based upon these set of fundamental quantities, we can derive the units of the other derived quantities. So we will be able to find out what is the unit of the other derived quantities in terms of this set. So that is the importance of giving this system of units. Popularly we have these three systems guys: FPS, CGS, MKS, which is later extended into what SI system. So what is FPS system? The names have come from the first letters of the fundamental quantities units. Length in FPS system is foot unit, mass pound, time is second, that's why FPS. CGS, length is centimeter, mass is gram, time is second, that's why CGS. MKS name has come from the first three letters. Length is meter, mass is kilogram, and then time is seconds. This MKS only further extended into what? The SI system of units, the system international. So this is what we'll be mainly focusing on. So if you look at the SI system, we have these units for the fundamental quantities. What is the SI unit of length guys? Meter. These are the things that we already know about. Symbol for the meter is what? M. What is the SI unit of mass? Kilogram, kg. What is the SI unit of time? Second, S is symbol. What is the SI unit of electric current? Ampere. Symbol is what? A. What is the SI unit of temperature? Remember, Celsius or degree centigrade is not the SI unit of temperature. We have one more unit of temperature, degree Fahrenheit. This is also not the unit of temperature. What is the SI unit of temperature guys? Kelvin. So symbol is what? K. Then amount of substance, SI unit is what? Mole. Symbol is MOL. E will not come. Okay. The SI unit of luminous intensity is candela. Symbol is CD. We have two supplementary quantities. For plane angle, the SI unit is not degrees, because the angle in a plane generally will talk in terms of what? Degrees, but degree is not the SI unit. What is the SI unit of angle guys? Radian. And the symbol for this is what? RAD. You know the conversion. The angle in radians will be equal to pi by 180 into angle in degrees. This is the conversion, because 180 degrees will be equal to pi radians. Solid angle, the SI unit is steradian, and the symbol for this is what? SR. These are the SI units of the fundamental and supplementary physical quantities. Now the SI units of the other quantities, right, they are basically related to the SI units of the fundamental and then supplementary. How they will be related? Like if you talk about velocity or speed. What is speed definition? Distance by time. Distance is given in what? Meters. Time is second. So meter per second. Acceleration is what? Rate of change of velocity. Means change in velocity by the time. Change in velocity will be velocity unit only, meter per second. Divided by time is what? Second. So totally what is it guys? Meter per second square. Momentum is what? Mass into velocity, means kg into meter per second. Impulse is force into time. The SI unit of force will be called as Newton, and time will be second. So impulse will be what? Newton into second. Force is mass into acceleration, kg into meters per second square. This is what is given the name Newton for the honor of work that Isaac Newton has done on forces and the laws of forces. Then we have pressure. Pressure is force by area, so it should be Newton divided by meter square, but this is called as Pascal in honor of the scientist Pascal, who has done a lot of work on pressure and the laws of pressure. So SI unit of pressure is Newton per meter square only, but we will also call it as what? Pascal. Then energy, kinetic energy is, what is the formula for the kinetic energy? Half into mass into velocity square. That is the formula for. So mass is what? Kg. Velocity square means what? Meter square per second square. This is the half, will not have any unit. So this is the unit for kinetic energy, which is being called as joule in honor of the scientist Joule, who has worked on the laws of thermodynamics. Then power is work done or energy divided by the time taken, means it should be joule per second, but this is named also as watt in honor of the scientist James Watt. Then density will be what? Mass by volume. So mass is kg, volume means what? If you look at volume of a cube means length cube, so it will be meter cube, so kg per meter cube. Then we said angles are related in science because of this angular motion or circular motion. So we'll talk about angular displacement. Normally the displacement means what? Shortest distance between the initial point and the final point. Angular displacement will be represented in terms of the angle covered. So it is the angle covered. So angular displacement will be given in terms of what? Plane angle, which is the radians. Angular velocity will be what? Angular displacement by the time taken, radians per second. Angular acceleration means what? The rate of change of angular velocity, means angular velocity radians per second divided by second, means radians per second square. So this is how we are going to get the SI units of all the derived quantities. So we have looked at the quantities related to the mechanics. So all these things, right? Velocity, acceleration, momentum, impulse, force, pressure, kinetic energy, power, density, angular displacement, angular velocity, angular acceleration, all of them we will get in the mechanics part of it. Okay, and there are more. I mean, this is just one set. Then we have other than this, in mechanics itself we have some more quantities, like we have moment of inertia, we have potential energy. So there are some more quantities that we will be talking about, angular momentum. And other than mechanics, we have the quantities related to the heat and thermodynamics, the quantities related to the electricity, the quantities related to the magnetism, the quantities related to the optics and light. So we have so many more physical quantities, but all the physical quantities units are going to be related to the SI units of, if we are talking about the SI unit, the SI unit of any derived quantity will be related to the SI units of the fundamental physical quantities and the two supplementary physical quantities. So this is how we are going to find the SI units of all the derived quantities. So this is what we have to cover in terms of the units and how the idea of units is used to relate between different physical quantities. And broadly, if you look at it, guys, what we have covered in this session, we have talked about what are the units of a fundamental physical quantity in terms of different systems, and how using the fundamental physical quantities units we will be able to find the units of the derived physical quantities. And we talked about how do we do the conversion between different standard units, and we talked about the classification of physical quantities into fundamental and derived, on what basis we are classifying them as fundamental and derived quantities. And we also talked about the supplementary physical quantities, which are plane angle and then solid angle. So in the next session, what we will be looking at is, we will look at the idea of dimensions and how the concept of dimensions will be used to relate the physical quantities. So in this session we have talked about how the concept of unit is used to relate between the physical quantities. In the next session we will see how the concept of dimensions will be used to relate the physical quantities. Okay guys, so just go through this session. If you have any doubts, you can just post it to us. We'll clarify it. And if some of you have not gone through the first and second lecture videos, you can probably go and take a look at it, and we'll see as it goes. All the very best, guys.